It's your vlog, not mine.
Okay,
My vlog.
I'm working on mine right now, see?
I've actually been in here in about 2 months, so
That's okay.
No, I sat down big enough to move things out of its out of its
Oh, I see.
orbit, and because it's not big enough to move things out of its orbit, I got kicked out of the Planet Club. As I
So
like to
dumb.
say. So that's why.
Lame.
So it's too small.
I still call it a planet though.
There is
Did they replace it with something?
no.
no.
So
Replace the planet, Elizabeth.
Shut up.
Oh, look, there's something right in the corner.
can you find my mom's house?
I'm gonna find you the. There it is.
Oh.
That is so cool.
That is like freaking weird.
Where? There it is.
Where?
All right, there's the ball field.
Is that the fountain over there?
Yeah.
Oh, that's planetarium. That's planetarium right there. That
Well, it
round.
looks like we're looking at us.
So.
Wave, honey.
We are right there.
That's what I thought. Wow.
Whoa.
That's incredible.
Whoa, why is it? Oh, because I'm using this. Okay, fine.
That is cool.
That is weird.
And then we zoom back out.
Whoa.
And then you can also look at.
Elizabeth, let's go.
It's either making fun of
Did
me.
I hear my name?
You know about it.
Here's the moon.
Okay.
We can zoom in.
Huh?
Find.
Can you find the flag?
Probably. I don't know where it is though.
Yeah, I don't know.
I don't know
where-
how far you can zoom in.
Apollo 11's flag blew over when they took off.
Did it
So,
really?
Yeah, so they spartaned up and all the other landings, they put it farther away so that it wouldn't blow over when they took off.
Wow.
What are you talking about? We were never on the moon.
It looks better on my screen, so I don't know why.
That's all right.
It's projecting.
Brother, shut up.
Whoa,
That's Jupiter?
that's Jupiter.
Where's the ring?
No, Jupiter doesn't have rings.
Yes, it
It
does.
does.
Oh, that's right. It
It
does.
doesn't show up. though.
All the gas giants have
I
rings.
forgot that it does. They didn't think it did for a long time, and I've forgotten that.
I can ask questions. Jeez.
Here's Io, the first moon of Jupiter. It's the
Oh,
most
Io,
volcanically
okay.
active body in the solar system.
And a what?
It's the most volcanically active body in the solar system.
Oh, volcanic. Okay. Is that what those dark spots are, like the volcanoes and stuff? Andrew,
What?
like that big dark spot down there in the. That-
Yeah, that's one volcano.
That's what, okay.
I don't know why Mars isn't on here.
How
It's
does
not?
it have volcanoes?
No.
Oh, bummer.
That's this is Europa. It's a giant ice moon of Jupiter.
The whole thing is ice.
The whole thing is covered in ice.
Wow. Oh, covered in ice.
Looks like somebody shot a bullet in it. It's got a hole that shatters.
Ganymede. I don't really know much about this one. It's another moon of Jupiter.
Yeah. When we went to that Hubble
And here's
exhibit,
Callisto. This is the fourth Galilean moon of Jupiter.
the fourth what of Jupiter?
Galilean moon.
Oh, the like big.
Yeah, it's the one that Galileo discovered. What's this?
A big red dot.
Red matter.
Whoa.
No, it is not red matter. I don't really know what this is. I think that's broken.
What's red matter?
It's from a Star Trek movie.
Oh, pfft.
Of course it is. How silly of me to
So,
ask.
Solar system view. So let's
Oh, those are the orbits of the planets.
turn
Well, that's
on.
kind of cool. That's a cool perspective.
I've also heard that Pluto has an elliptical orbit, but I don't think that matters for planet's sake.
Why are the stars there?
Because
those are like sunspots?
Yeah, those are sunspots.
Okay, got that.
And then, oh, because it's centered at the sun. Okay.
So there's
What's that third one right there?
Mercury, Venus, Earth.
So, alright, I
Mercury.
need, alright, let's
Mars.
So,
Oh, that's Mars. Okay. Mercury's the closest. Mercury, Venus, Earth, Mars.
alright, so this first, let me see. Oh, never mind, I just clicked on it. So we're gonna go to Mercury first.
Whoa! Wow.
Here's Mercury, it's the closest to the sun. It's cool.
Now these are the actual colorizations of these?
These, everything in here is actual real data.
Mercury comes first.
So
Huh.
this was actual pictures taken by orbiting spacecraft.
Okay.
And then we move on to Venus. This is actually the surface of Venus. So this was taken using basically a special camera that could look through all the different clouds.
Oh, sorry, because I know.
Venus is just covered with the
Yeah.
clouds. Imagery.
Earth.
Saturn.
Then moving on to Earth. Next one out.
Dirt rock in the sun.
And then if we look, I need to find it. There's the moon over here. Over
Oh, right there. Okay.
there is the
Okay.
moon. So what I can do is I can set this to go at a fast speed.
Oh,
And you
cool.
can watch everything rotate and then
Wow.
the moon's orbiting. And
Cool.
next up is Mars, the red planet. The
Oh,
northern
all right. Polar ice caps. Okay.
and the largest volcano in the solar system.
Oh, two polar ice caps. So
How
that,
do
like gray
planets-
spots are like
The
the.
resolution should be really
Ouch.
good.
It's okay. Let's
Oh,
let's
Another
look at
thing we can do,
it later.
so everything here is like large, blown up really big, so you can see everything to scale, or so you can see details. If I were to change everything to be to scale, this is what it looks like.
Oh, okay.
So that little tiny dot in the center is the sun, and you can't even see any of the other planets.
Just the orbit of them. Wow.
So if we go back to Earth, and zoom out, you can see there's the moon out there. Now if we were to make everything to scale, that's, let me see if you can see it better. But you can see how far away it really is. So that's the Earth, and then that little tiny dot there is the moon.
Barely see a dot.
That's what it is to scale.
Whoa.
And then now we go on to Jupiter, which is a pretty sweet planet.
Andrew, how many times have we been to the moon? Twice or 3 times?
No, I think we've been there more than that.
It was like
Wow.
6 or so.
Yeah, I want to say like about 6 or so.
This was Apollo 11 through 17, not including 13, because that one didn't land.
I know.
But if you include just flybys, then you would include 13, you would also include Apollo 8. And I think also maybe Apollo 9 or 10, one of the two.
No, because Apollo 11 was the first to go.
Correct.
What happened with 13? Oh, 13
Yeah,
was
but
the
Apollo
one that-
8 didn't land, but it orbited the moon with humans.
Well, I was
So
only
the cool thing about Jupiter you notice, these 4 inner moons, let me get them lined up. Come on.
They move so quickly. How many rotations do they make?
Infinite?
No, but I mean, like, how long does it take to make one rotation?
So this inner one, right here, orbits every, I don't know actually. But what I do know, and what's cool, is this one, the second one, takes 1 orbit in the time it takes the inner one to make 1 orbit. And then this third one makes 1 orbit in the time it takes the inner one to make 4 orbits. So if you watch them, what happens is they all get lined up, or they should, I don't know why not. And then this one makes 2 orbits and it's lined up with this one, and then this one's on the other side. And then this makes another 2 orbits, and this makes it back, and then this one makes it back.
Oh,
So
I
every
see.
4 orbits, all 3 of these moons are all lined up together.
The 3 inner ones.
Yes.
Elizabeth, you know that thing at OMSI where you have marbles that go round and round and round and round and round the thing, and they finally plop down in the very middle?
Yeah.
That's to represent how the planets, go in orbit. So the bigger the planet, the further away from the sun the planet is, the slower its orbit is.
Oh, I see. Okay.
Yeah.
So as you can see, these 2 are
Those 2, yeah, I
lined
see
up.
that.
And if we watch the inner one, it makes 1 orbit, and then the second one is halfway around.
Oh, okay.
So when do they all 3 get lined up?
It might not be 4
Oh,
perfectly, so that's why it's not working.
that's
When
alright.
Jesus was born.
Oh, no, they are lined up, just not on the same side. Never mind, so hold on.
If they were across this.
Pretty much the most awesome planet in the solar system.
See, I was able to see Saturn and its rings with my telescope.
Oh, that's right.
So you can see all of its rings.
So what's the top that's there in that dark spot?
It's just the pole.
Oh, okay.
Yeah, it's just like the North Pole. The
What is
reason
the
this
ring?
all kind of looks weird is just because of the data that the pictures were taken in.
Oh, okay.
You have to extrapolate. And then of course the shadow back here is from the sun over there.
Oh,
What are the
okay.
rings made of?
Huh?
What are the rings made of?
The rings are made out of dust, not really any gas, mostly dust and rock and ice. Yeah, they're not solid. They're very, very loose. It's just a bajillion of them, so it looks solid. And so right now it's inclined, I think about like this to us, so you can see the rings. But every so often, I don't know how often, but the planet gets aligned perfectly like this, and we can't even see the rings anymore.
Huh, wow, that's strange.
So it kind of wobbles back and forth like this. So now we move on to the next one. This is Uranus. It's not really that exciting.
Why?
Well, look at it. I mean, that's pretty much what it looks like. It's
It's
just,
blue.
Do we know very much about the gas planets Neptune and Uranus? The planets
what do
that
you
are
mean?
a little farther out?
What was your question? I didn't hear.
Do we know very much about the planets that are farther out, like Neptune and Uranus?
About as much as we do about all the other ones, because we've sent Voyager, I think 1 has gone through all of them. So we know some things about them, but there's still a lot we have no idea.
Hey, Andrew, this planet, doesn't it rotate a different direction? I thought there was one that did.
No, that's Venus rotates the opposite direction. What this one does is, if you'll notice, this white line over, this white line is the orbit direction, and if we watch, it's going to rotate not kind of like along it, but it's just a very inclined orbit. Let's see if I So if you'll notice, so
Yeah.
this white line is the direction it orbits, and you can see it's rotating around like this.
Yeah, that's what I was saying. Yeah.
Whereas other planets, which I'll show you on the next one, don't do that. So let me pause this. Move on to Neptune. This one's a little bit more interesting, but it's still mostly just blue. Why? What the heck? It looks different on here. That's okay. Where's my elevation maps? Hold on.
There's the sun way down there.
Okay. Well, anyway, so this is Neptune. So if we watch this one over time, you'll notice it spins the
The
direction it's supposed to based on.
Yeah. It goes down.
So like if we look from like a top-down view,
It goes counter.
it's doing this thing it's supposed to be doing, essentially.
Yeah, it's rotating counterclockwise.
So what causes the other one to rotate a different direction?
God.
We don't entirely know. We think what happened is, oh, this was so long ago. I think what we think happened is that Uranus was actually like much closer to Jupiter and Saturn, and then it basically got knocked out of its orbit and got pushed further out. And then when it did that, it just it didn't align correctly anymore. Yeah, it's not that exciting.
Oh no.
Want to be a little more exciting once that probe gets to Pluto and we can actually learn something about it?
Yes, it will. We do know. We just discovered a couple extra moons of Pluto. I don't remember what the final name was for that was.
So what's the definition of a moon then? Just something that goes around a planet?
It's anything that orbits a planet that is so like each and every one of the particles in Saturn's rings is not a moon, because I think there's a minimum size for it, but I don't know what the specific definition is. But pretty much anything that orbits around a planet is considered a moon. In here.
Why are
So
they?
each and every one of these tiny dots is an actual asteroid, and
Wow.
every single one of them have been mapped. So as we can see from a top-down view,
There's the asteroid belt.
all these things in here, that's the standard asteroid belt. So we can watch it move forward.
That's between Mars, Saturn, and Jupiter.
Faster, faster. There we go.
Yes.
So now you can see. Oh, that's too fast. No.
What causes asteroids to fall?
So now you can see each and every all these asteroids going around the planet or the sun. Let's try to get in among them. Some of those might actually
Yeah.
be comets or something. So now if we come like down into the plane, you can see them all moving by.
Wow.
Why are they different colors?
Just designations. So like each color represents a different like chemical composition, I think.
Wow.
They don't actually look like that.
What makes asteroids fall?
They don't fall. What happens is, what do you mean fall?
Well, like if something falls, like if an asteroid
Like when
hits the
meteorites fall to the earth.
Is that what you're asking?
I want to know how asteroids hit the Earth. What causes that?
So basically what happens is since Jupiter is just so incredibly massive, it can basically have gravitational effects on the asteroids near it, and it can make them kind of get out of this stable orbit. So sometimes it just shoots them out of the solar system and they're gone. And other times it just kind of picks them up and then shoots them back inward. And then if everything's lined up just right, it can be shot back in and then collide with the Earth.
That's so cool.
Those are called the Trojans. And they're 60 degrees ahead of Jupiter's orbit and 60 degrees behind it. And they're basically in that spot because of the gravitational pulls between the Sun and Jupiter are kind of just right that they can just stay there.
Oh, okay. What kind of objects?
Kuiper Belt.
Okay,
a
okay.
dude named Kuiper.
Yeah.
And Pluto's actually one of these. And it's basically just like a secondary asteroid belt. So that's about it for the solar system view. Now,
And then Andrew comets are ones that just kind of pass through.
comets, I don't think their data sets are in this yet.
Okay, that's fine.
Because this is still a pretty new thing.
That's all right. Whoa.
Now, no. It's just the way the picture was taken.
I'm just being obnoxious.
Yeah, I know. But it's good practice for when I'm doing this for middle schoolers. No,
So,
that's
are
just-
you going to be a teacher then?
No, but because I'm trained to use this, I can give planetarium shows for people who come here.
That's so cool.
So like Boy Scouts and Cub Scouts.
And you can deal with the obnoxious children.
Because they're obnoxious.
So how long are you planning on staying in Seattle?
I don't know. This is what it looks like in infrared.
Well,
That's
kinda
cool.
I like that.
Let's see. So, we zoom out. On a dark night from Seattle, it'd probably look about like that. Maybe like that.
Wow.
It's called that because
Oh yeah, yeah.
it looks like a horse head,
It does
apparently.
with the eye. Okay. Yeah.
I guess it's the only picture we have of it in the system. What's the other one that's really famous is the Eagle Nebula.
What causes the colors?
Some of them are more or less real, and some of them are just basically photoshopped to make it look cool.
So how do you know what's real and what's not?
You don't, but the people who work on this stuff do. So if we zoom in here, this is like the famous Hubble image. What is it? There. Should turn off. Stop. So that's another just thing in here.
How do we discover things like this?
Hubble mainly. Most of all these nebulas and stuff is all just Hubble images.
So what's the definition of a nebula?
Nebula is basically a region where a star has gone nova or supernova and basically died, and just like all the gas and stuff that's left over.
Ah, okay.
The other thing is if stars are forming in the region.
Oh, okay.
So like in this one, not this one, in the one we looked at before, the Eagle Nebula, in the center was a, nope, that's wrong too. I don't remember which nebulas, but in some of them, it's just stars that are forming, so they also look, they have, the gas gets lit up and stuff.
So a nova is like when something like, well, basically like explodes or expands or
Yes.
that type. Okay, so that's what that means.
I
Okay.
don't know why all that orange is there. actually a star-going supernova. And then when astronomers looked in that region with the Hubble Space Telescope, this is what they saw. So this is the result. This is what happens after about 1,000 years after a star goes supernova.
How long do stars live?
It depends on the mass. So stars of similar mass to the sun last for about 10 billion years. Stars that have a lot more mass only last for maybe like 100 million. And stars that are like pretty much the lowest mass they can have can last for about 1 trillion years.
Wow.
So pretty much forever.
How do we measure that kind of thing? How do we measure how long they last?
Models essentially. So the way a star works is it's basically just a giant ball of hydrogen gas, and it fuses that hydrogen into helium. And basically what we can do is we can measure how much hydrogen and how much helium is in the star, and that can tell us how long it's been burning or fusing hydrogen. And based on the mass, we know how big it is, and we've used that information to be able to build models to figure out how long stars of different masses can last. That's more what it looks like.
That's pretty.
You can also see this with a good telescope. So this is actually two galaxies going through a merging process. So we have the big central galaxy in here. And then we have this other galaxy that came along and just started to kind of interact with this one. And eventually they're going to merge. And kind of an intermediate step between those two is, I don't know what it's called. Hold on. This actually worked about 1.5 years ago. But like you can see, it's based on the dials and
I see
everything.
the
It's-
dials,
Oh, missed one.
There's a couple that looks like they're still up.
Fail.
Well, the signal bounces around, so.
Oh, they're okay.
Yeah, and there's a very, very, very loud sound system.
I was gonna ask if there was a sound
Yeah, you
system.
see that?
Yeah?
Yeah, that's one of them. There's another one, and then they're kind of,
I thought I saw one, I think there was one there,
there's
and one there.
these things, these are speakers back here.
Yeah, that's what I thought.
Definite surround sound.
Oh, yeah.